So now that we've seen how to get information about a function by looking at its graph, we're kind of going the other direction when we're going to see how we can answer some similar questions about a function if instead of a graph we're given a formula that describes it. So I've got a function here and I've got some questions about it. All right, let's walk through these, see how we can answer them, right? Is the point 3 comma -1 on the graph? Well, to answer this, remember that the x-coordinate of the point is 3, right? So what I'm going to do is I'm going to calculate f of 3 and see what that equals. If it equals -1, the answer is yes. If it equals anything else, the answer is no. So this will be 3 minus 4 over 3 plus 2, which is -1/5, which is not -1. So my answer here is no. That point is not on the graph. All right, so my second question, if f of x equals 5, what is x? Well, remember, this f of x, this is the y coordinate. So what I'm saying is if y equals 5, what is x? Well, okay, let's figure this out. I'm going to put 5 in here for f of x, and then just solve this equation. Right, let's multiply both sides by x plus 2. And then I'm just going to solve this. This is 5x plus 10 equals x minus 4. So let's see, 4x equals -14. X is -14/4, which is -7/2. So what does this tell me about the graph? Well, this tells me that the point -7/2, comma 5 must be on the graph. All right, so next question here, what is f of 5? And again, what does this tell me about the graph? Well, f of 5 is 5 minus 4 over 5 plus 2, which is 1/7. So that tells me that the point, remember this 5, that was the x-coordinate. So that tells me that the point 5 comma 1/7 must be on the graph. Okay, so how about intercepts? Remember, to find the y-intercept, we set x equal to 0. So this is going to be y equals f of 0 equals 0 minus 4 over 0 plus 2, which is -4/2 or -2. So that's the y-intercept. And to find the x-intercept, we set y equal to 0. So the equation then will be 0 equals x minus 4 over x plus 2. And again, just like we did up there when we're doing this with when y equals 5, multiply by x plus 2. 0 equals x minus 4. So x equals 4, and that's our y-intercept. Our x-intercept, right? And finally, what's the domain of f? Well, this is a rational function. We have variables in the denominator. That's always a little bit of a concern, right? So our denominator says that x plus 2 can't equal 0, which means x can't be -2. So the domain will be all real numbers except -2. And that's it. Right, there's the answers to all of those questions. All right, so I've got another example here. There actually is a little bit of a twist to this one. So you can go ahead and pause this if you like. See if you can't work through these on your own. Then come back and we'll go through them together. All right, so when I see something like this, my first instinct is to see if I can simplify it, right? Because as it is, it's a little messy. So what I'm seeing here is that I can factor an x out of the top. So it'll be x times 2x plus 3 over x times x squared minus 4. And then these x's are going to cancel. And I'm left with 2x plus 3 over x squared minus 4. Now, that is not strictly speaking true. I know I've taught introductory algebra classes, and I've taught students to do this, and I cringe inside a little bit every time I do, because this expression is not equal to this one. It's almost equal to it, but not always, right? Canceling out these x's was a little bit of a sketchy thing to do, right? And I just want you to hold that idea in the back of your head. When we get to one of these questions down here, it's going to become an issue, right? And I'll circle back to that and point out why when we get there. All right, so we've got some similar questions here, right? Is the point 4, -1 on the graph? Well, I'm going to work with my simplified version here. F of 4 is 2 times 4 plus 3 over 4 squared minus 4. That's 16 minus 4, 11 twelfths, which is not equal to -1, so no. That point is not on the graph. So my second question here, when f of x equals 2, what is, -2, what is x? So let's replace f of x with -2. That's going to be 2x squared plus 3x over x cubed minus 4x. Well, sorry, we'll use our simplified version. I grabbed the original. Let's do 2x plus 3 over x squared minus 4. So let's multiply it by the x squared minus 4. -2 times x squared minus 4 equals 2x plus 3. -2x squared plus 8 equals 2x plus 3. And that's a quadratic equation, right? So let's set that equal to 0. Minus 2x squared minus 2x, subtract 3 from both sides, plus 5 equals 0. And I'm not feeling super good about factoring that, which is unfortunate, but we can still answer the question, right? I'm going to use the quadratic formula. X equals -2 plus or minus the square root of -2 squared minus 4 times -2 times 5, and I'll put that square root in there, over 2 times -2. All right, so now it's really just an arithmetic question. This becomes 2 plus or minus, what's going on under this square root? We've got 4 plus 40, I believe, so this will be the square root of 44 over -4. Let's see, 44, that's 4 times 11. So this is 2 plus or minus 2 square roots of 11 over -4. And we can reduce this. This is 1 plus or minus the square root of 11 over -2. Okay, not the prettiest answer I've ever seen, right? But that's okay, right? That is, those are two perfectly good real numbers. So my answer here is, how does this translate to a point on the graph? The point 1 plus or 1, that's going to be a fraction. 1 plus or minus the square root of 11 over -2, comma -2. Those points must be on the graph. All right, so I'm going to keep trying to. I'm going to have to erase some of this in a minute, but let's see if we can't just jump over here to the side for the next one. What is f of 3? Well, f of 3 is 2 times 3 plus 3 over 3 squared minus 4. So let's see, 6 plus 3 is 9. 9 minus 4 is 5. So f of 3 is 9/5, which means the point 3, 9/5 must be on the graph. Okay, so what are the intercepts of the graph? Okay, well now I am truly running out of space, right? So I'm going to have to clean up a little bit. I'm going to clear out this section over here. right? And we'll work over here for a little bit. All right, so remember how we find intercepts. To find the X intercepts, we replace Y with 0. So X intercept, I'm going to replace Y. That's the f of X with 0. So this will be 0 equals 2x plus 3 over x squared minus 4. So clear the x squared minus 4, multiply both sides by it. 2x plus 3 equals 0. 2x equals negative 3. X is negative 3 halves. Right? And there's my x-intercept. All right, and how do we find the y-intercept? To find the y-intercept, we replace x with 0. And here's where I have to stop us. Right? Here's where we can potentially get into some trouble. Right? If I can put 0 into my simplified version, and that's fine. All right? But try putting it into the original version. Remember, the original version is the one that really counts here. If you try putting this into the original, you get 2 times 0 squared plus 3 times 0 over 0 cubed minus 4 times 0, which is 0 over 0, and that is undefined. You can't divide anything by 0, including 0, right? So there is no y-intercept. And what the rule here is, when you cancel out a factor from the denominator of an expression, you have to be aware that even that factor that you canceled out can never be 0. Right? And let's look at the next question here. Let's look at this. What is the domain of f? Right? And to do this, we really need to go back to the original function. All right? To find the domain, we need to know where is that denominator equal to 0. All right, so polynomial equation. I can factor this. This is x times x squared minus 4, which is x times x plus 2 times x minus 2. So I'm going to get 3 bad numbers here. X equals 0, x equals 2, and x equals negative 2. These are the values that are not in the domain. So the domain is all real numbers except plus or minus 2 and 0. And now hopefully you see where the problem is. The function is not defined at 0. So we can't do this over here. We can't substitute 0 for x. The function isn't defined there. Right? So my answer here would be the function has an x-intercept at x equals negative 3 halves, and it doesn't have a y-intercept because it is undefined at x equals 0. All right, so that was a little long, right? There are a lot of different questions to ask, and the second one in particular required some calculations. But hopefully you've got an idea now for the information that we can pull from a function in its various forms. And in the next lecture we're going to kind of start a new series. We're going to look at kind of more general properties of functions, starting off by thinking about where is a function increasing versus decreasing.